When I came here, what I learned was that many people were interested in gleaning some interesting information or useful information, at least, from this text they were just storing. So that's really where we took off. It's sort of, I applied my domain-specific knowledge of text mining, machine learning on a wide set of types of language in historical archives and applying to archive the data sets that we have here. I was hired to be the director of the Digital Scholarship Center, and that has grown. So just some background on what Digital Scholarship Centers and studios are. DSCs are a global trend now. They started picking up around 2012, 2013. And they're library-based centers. And they're library-based centers that try to engage directly with teachers, scholars, researchers, etc. And it's not service-based. So the difference here is that many library centers in the past have been cleaning your data, acquiring data for you, getting licenses for you. Digital scholarship centers want to be more active, scholarly collaborators with the academic community, students, faculty, etc. Why the term scholarship? The term digital is pretty obvious. If you use technology and different data types. Scholarship is a term that's all intrinsically multidisciplinary, and it spans the entire information ecosystem of a given campus. So scholarship encompasses research, teaching, and service. So we try to have a broad net of what we consider to be academic and scholarly activity. So all the way from research to student projects and teaching, all the way to sort of service and operational projects. We do some optimization and operational efficiency projects, the Office of Research, for example. So we try to have a broad net. What we have done very well here and what distinguishes our DSC is that we are not just multidisciplinary in name. There are many DSCs out there that are interdisciplinary, sort of caught in between the boundaries and silos of different disciplines. What we've tried to do, and many of our funding agencies have described this to us, we draw from a broad range of disciplines, but we are grounded and centered in disciplines. So we work through multidisciplinary practice, that we deal with collaborators that are at the heart of their disciplines. They know their disciplinary subjects and arguments and debates really well, but we bring them together to sort of like a team science approach that Jack is an expert in. We assemble research and scholarly groups, and we embrace people trained to think very differently about every step in the research process. So we do not assume any technical background. We do not assume a certain methodological orientation. And our goal is to try to get people to work together, honestly. What we've been able to do well is to compose and sustain partners that really work together through the entire research lifecycle. And I say that because oftentimes with certain collaborators, people drop in and out. Early on, librarians come in terms of getting data sets or helping with initial data analysis, or later in evaluation and assessment. Technical collaborators come in and out, in the data analysis part. What we try to do is have everyone at the table early on, at the initial formulation of research questions. So everyone's voice is there. So a computer scientist or a librarian or an art historian or an MD would all have different ways of framing their research question. What we do then is we identify grant opportunities that can support this multidisciplinary work, oftentimes in multiple fields. So NIH, NSF, the Mellon Foundation, et cetera, to support different aspects of the work. And a lot of our work is, let me put it like this, I've been on several large multidisciplinary grants in my previous institution. That stopped there. They sort of brought teams together, they said, here's some grant opportunities, and they said, okay, smart people, make it happen. And those failed. I noticed, I was part of a $1.6 million grant that tried to, at the University of Iowa, that tried to do that. And the philosophy was matchmaking and get the smart people around the table. And that did not work for many, many reasons. So for better or for worse, at that job, what I had to do is sort of drag people across the finish line. As a one-man person, I had to sort of get the data set, do the analysis, do the visualization to get people to actually engage with each other. So learning the lessons from that, that's why we actually do engage with the teams in identifying data sets, cleaning them up, manipulating them, and getting them ready for all the stakeholders. We also are actively involved in the data analysis. A lot of our work is in machine learning. We'll supervise classical and more recent deep learning innovations, and we try to apply the methods in a way that are legible and usable by our different collaborators. And visualization, I'll show you in a second why visualization is important. So everyone is sort of able to interpret and analyze and glean useful information from our data. And finally, argument formation and publication of findings. What we found is that what is plausible and what is a plausible, burden of proof for different disciplines really varies. So what we're able to do is sort of have multiple outputs of our projects based on sort of disciplinary standards and disciplinary venues. Our core philosophy methodologically, machine learning, AI is a family of machine learning, machine learning is a family of this broader bucket of AI. AI gets a bad rap these days. What I would describe machine learning as, it's just pattern recognition. It's very powerful pattern recognition, where you do not need to feed in rules. It can identify the natural distribution of patterns that might not fall along sort of predicted distributions of data. So machine learning is powerful because you can apply it to any data. And so what our one of our initial collaborators and supporters, a geologist in the College of Arts and Sciences, said he found the way we use machine learning fascinating because it's literally a borrowing of techniques. We're taking machine learning and dropping it in different disciplines, learning what people need, what their research questions are, and adapting the machine learning technology to their research questions and their data types. So we are really trying to apply machine learning as a discipline agnostic method, rather than just being focused on data science or computer science. Our initial push, so we have two phases. The first phase was a $900,000 grant from the Andrew W. Mellon Foundation. Mellon Foundation is the largest funder of the arts and humanities and the libraries in the U.S. They're a private foundation, obviously. Their specific goal for this grant was to advance our Catalyst model of digital scholarship. That was our first model, or the way we described our model, a catalyst to move beyond the matchmaking and getting the smart people on the table phase. How can we use machine learning in our infrastructure and techniques and know how to actually drive the reaction forward, push people into scholarly results? Mellon supports, I've been a Mellon investigator before the last $1.6 million grant. What I've seen is Mellon supports long-term culture change. So they're not interested in incremental, like what is the state of the scholarly literature and how can we go to the next step. They're interested in really thinking in 10 years, what does the higher education landscape look like? What does the research and scholarly landscape look like? And what are steps that we can do that in an intentional way rather than the sort of scattershot way? So we were part of a digital integrator initiative that they had with six peer institutions across the nation, which I'll explain in a second. We had three major aims for the digital integrator grant. One was to model new strategies and practices for transdisciplinarity. We have an advisory group that's writing a white paper. It's observing our methodology, how we constructed our teams, and our sort of center culture, basically. How have we translated between disciplines that rarely interact and oftentimes are adversarial? And the secret sauce, if there is one, is we connect domain experts with technical experts. We have many colleagues in computer science, data science in the business school, bioinformatics on this side, biomedical informatics on this side. And we create teams to connect them with subject matter experts that are in the heart of content fields. However, we make sure that translation is a key word here. We make sure that both the domain specialists and the technical specialists feel comfortable within that space working together. And that is no small challenge, but that's a lot of the work we do, creating that translation, that safe space to work together. A lot of our $900,000 seed grant from Mellon was to provide resources and infrastructure for research questions and collaborations that slip between the cracks of funding agencies. We work with a lot of investigators, early career investigators, and also late career investigators that want to branch out and feel like they want to branch out from their original body of research, but they cannot find time and resources to support the effort to sort of branch out into a new area. That's what we do. We provide resources, funding, know-how teams, allow people to have 1 or 2 years to not to retrain themselves, but to establish a credible track record of research in a new field using machine learning and using data analysis in different ways. And finally, more practically, all of the tools that we're producing, which I'll show you in a second, we're producing a machine learning platform for any text data set. So we're going to release our transdisciplinary computational tools and all of our visualization modes as human interpretable research projects. So those are sort of tools, products that we're going to share with the broader scholarly community. That was phase one. And we were among 6 digital centers and studios supported by this Mellon initiative. Our peer institutions were, in the first wave, the University of Illinois Urbana-Champaign, UConn, Brown, and Emory. And then the second wave was us and Duke. And what Mellon had funded lots of different library-based initiatives in the past. They were not happy with the outcomes. So this is the newest push for the big data era and the machine learning era. And what they wanted to support were leaders defining a new type of digital integrator, as they described, whose sole mission, they charged us to do this. Our sole mission was to collapse silos. So rather than stake out a claim in a college or the library or a certain entity, to reach as many people across disciplines as possible to break down silos. And within these 6 groups, there's a spectrum. Let's see here, Emory and Brown are more on the concierge end of things. Concierge meaning like, they're more on the front end of that research project process. They bring people together, they guide people to grant opportunities, they get data sets and databases, etc. And we're on the far other end, to describe the catalyst end of the spectrum, where we actually dig our hands in, roll up our sleeve, and help people do the analysis and get publication-ready results. So there's a spectrum there, but that digital integrator vision is sort of that overall umbrella. Long-term Mellon in phase 2 of their projects, we're all heading up toward renewals now. And they want to help concretize us and crystallize us as hubs in the academic research ecosystem. One way I would describe it is, we presented to the Board of Trustees and the Provost recently, and the Provost said, you guys sound like Google. Like you're aiming to be Google for our campus. And I think that's fairly accurate. It was sort of a joking comment, but if you look at Google's mission statement, all the way from 1999 when they were founded, it's Google aims to make the world's information accessible and usable by as many people as possible. Search is not there, but it's information, accessibility, and usability. So Google has this sort of carpet bombing global approach, which the drawback of that is fairly non-specific. What we hope to be is a Google for our campus. So specifically for the research and information needs of our campus, we want to make your information usable and accessible. So that's how we envision ourselves. Where we stand operationally and in terms of vision is we're heading to phase 2. So we were part of the first cohort of 6 anchor teams at the Digital Futures Building. There's a hole in the ground right now on Reading Road in MLK. We have so far leveraged the initial Mellon grant for $3.1 billion additional funding and grant funding from different sources. And we are heading in February for Mellon renewal. So if any of you are interested in any of these phase 2 operations, let us know, because we have lots of opportunities in the Digital Futures Building, in our extramural grants with different funding agencies, and our Mellon renewal. So we're aiming for around a $2 million renewal, but we're working on it. What I like to say, and I'm sure Jack is on board with this, what I try to tell people is that are initially skeptics is that there might be a sort of curve of learning and initial startup costs in terms of effort and money to work in a multidisciplinary team like this. But it's not just a feel-good story. What I've seen is, and what we try to convince people is that it helps everybody. There's concrete multidisciplinary outputs. So we've had from one project, we've had multiple publications in a range of fields. So rather than the one project leading to one publication, it's the domain expert is in their field, obviously. But then what we found is our methodological and technical collaborators, computer science or data science or biomedical informatics, they publish in the methodological field. And then we can also do collaborators, for example, in law and journalism, and they've distributed our work to the popular press. So there are multiple branches and outputs from a multidisciplinary project. And also, like I mentioned, we can get seed money from Mellon, and our support can lead to further grants for growth from other agencies. So the example I give is at my last institution, the $1.6 million Mellon grant entitled IO Digital Bridges started off with Mellon, but it led to subsequent grants from our investigators, Gates, NIH, NSF, NEH, and NEA. So we helped them start an idea, we gave them some momentum, and then they were able to get subsequent funds from other agencies. So it's sort of a domino effect, a virtuous circle. And I won't talk too much about the perspective on teaching and doctoral training, but that's what really digital futures is about. How do we get this multidisciplinary research culture that we're working on as a digital integrator? How to integrate that into doctoral training? I can answer questions about it. I'm not going to go too much into that right now. So how do we make this work? The rest of my talk, let's talk about different techniques we use. At a technical level, how do we get buy-in on one end of the spectrum from our technical collaborators? And the answer, to be short, is data structure. And I'll just tell you a little story here. At my first job, when it just came out of grad school, at the new faculty orientation, I met a woman, and she was a PhD in astrophysics and astronomy. And we joked that we were at the far ends of the academic spectrum. I was a Shakespearean working on historical linguistics, and she was an astrophysicist. But because of machine learning, we became close collaborators. And about 3 years into my first career, she found out that I was working with sklearn and different machine learning libraries and deep learning architectures. On a specific type of data, I was working with very sparse arrays. She started branching out into this, and she said, "Hey, James, what are your techniques for working with sparse arrays and sort of matrix factorization operations like that?" So here we were. He was an astrophysicist and a Shakespearean. The content of our data structures were different, but the data containers and the data structures we were using were the same, and we were using the same mathematical operations of them. So, and we're still very good friends. So I learned from that experience that data structures are a way to bridge different, although the content domains and the data types might be different by discipline, the actual mathematical operations in machine learning are shared. So we try to leverage that a lot. We can use, computer scientists can use their specialization in multiple disciplines. And here's just a perfect example. These are from 2 different publications, and on the left is a lexical co-occurrence network in Shakespeare's plays. And on the right are methods extracted from plant genetics articles in PubMed and JSTOR and Scopus and Web of Science from a certain subset. I use exactly the same algorithm to extract and cluster these entities, these nodes. But one is Shakespeare's plays and one are methods in method sections in scientific articles. So the content is content agnostic. The data structure is the same, and the data structure manipulation is the same. Both produces networks, but there's a sort of universality to this, which I think is kind of attractive. At the far other end of the spectrum, what we do is data visualization. So this is more for subject matter experts and domain experts. What I found very quickly is everyone needs a different type of display or resulting presentation of evidence in order to make inferences. So here's just an example. We're working on a fascinating project with the creative writing program in Arts and Sciences. And we're working with the second largest archive of audio poetry, sort of spoken readings of poetry in the nation. And so we're working with our computer science department, electrical engineering. Work on this archive, the poets needed the left. They needed the amplitude waveforms of the spoken word. And they wanted to see when words were spoken, they wanted to see the rhythm and beat, they wanted to see applause and laughter. The computer scientists we were working on doing the audio analysis, they did not want that. They wanted a high-level, 35,000-foot overview of what are we dealing with here. They wanted that kind of presentation of data. So in order to get the first conversation off the ground, we needed to take the same data set, but we needed to produce completely different visualizations or displays for them. And at that point, they felt comfortable coming in at different levels, speaking to one another. So we do that a lot. It's laborious, but I think data visualization is key. It's not just pretty pictures. It actually engages people on cognitive level that they've been trained in to engage with data so that they can speak to others, they feel confident about it. We do a lot of data visualization work. What we found, the third strategy we use are common data types. So one example is social network analysis. We do a lot of social network analysis. People are, this started off with social media analysis. There are many investigators and faculty members in disciplines study Twitter, Reddit, Facebook, etc. So that's where we started, largely on West Campus. But what we found was there was a demand for social network analysis in general, not the social media, but sort of between entities and nodes within a given system. So on East Campus, we've done this quite a bit, actually. It's sort of based on geospatial data or different demographics, identifying clusters and nodes of different patient identity, the patient cohorts or language, and like the method section that I showed, sort of identifying co-occurrence of methods within method sections. So network analysis is a big domain, and like I say here, arts and sciences, law, DAP. We've had 4 projects in children's, engineering, and the education college. They all are interested in network analysis, both in the quantitative sense. On the right, we do social analysis, network analysis metrics, but we also do visualizations of visual network systems. That's one large area of work that we do. The second large area of work that I think is most relevant to this audience is at the Academic Health Center is we have a lot of projects using machine learning to work through and make these piles of texts useful on this campus. So we extract salient features and cluster and classify free text. The two major bodies of text that we focus on, one is electronic health records. So we have lots of divisions and individual investigators that have certain patient cohorts, and they furnish us with the EHR for those patient cohorts, and we try to find underlying trends that might have been missed in the free text. The second body of text projects that we work on is in scientific literature. So we look at the now 30 million plus articles in PubMed, and we try to identify trends within the literature. Why is that important? One is several of our collaborators are interested in annual reviews and systematic reviews, and trying to find a big data, analytical way of doing that rather than the manual ways they've been doing now. Also, it's a sort of competitive intelligence tool. Some of our labs are very competitive to get grants, and our ones are harder and harder to get. So what they want to do is look at the NIH grant database and PubMed literature database to identify what are white spaces, what areas of research are heavily saturated, and what gets funding right now and what is getting published right now, but is not oversaturated with competition, so that they could tell, they know how to direct their resources, grad students and postdocs and energy in that area. So one is more research and the other is more sort of operational, helping people get a leg up in funding. So we just started off in the bio department in arts and sciences, but we're working with several departments in the College of Medicine. Our largest push has been with hospital medicine and children. Hospital medicine is very interested in our projects, but there's several social justice related divisions at Children's, like the Mayerson Center, the Czech Clinic, etc. So this is the same large body of research that we do. The $900,000 Mellon grant, the computational tools that I told you about are supported by the Mellon grant. And here's an example. We're trying to generalize and systematize our technology stack. So what we realized at first is for all of our disparate projects, to a certain extent, we were reinventing the wheel. There were certain steps that we're doing over and over again. So the Mellon grant is supporting a platform, an automated platform to sort of do some of the steps, the repeated steps that we do for every project, and just make a smooth pipeline to automatically do it. And just, I don't know what the details of this, but we've completed that now successfully. So here's some examples from different, in closing, here's some examples from different outputs we have. Early on, we did clustering analysis. So I think this is in PubMed, in one of the genetics labs we're working on. And this is just identifying the n number of most probable clusters within genetics articles that mention within the mesh headings over here. So they were interested in a range of mesh headings, and we extracted all of the articles with those mesh headings, and we found at the word level what words, what language is used together with a very high probability next to each other at the sentence and paragraph level. And then this clustering here is showing all of the statistically significant clusters that occur next to each other. And then for each cluster, I just highlight one cluster here, here's a list of words participating in that cluster. The information retrieval innovation that we've had is adding this pane. So you can, our users can click and identify, we list out every article and every paragraph contributing to each cluster, so they can look at all the articles listed together. What this does is, rather than organize the scientific literature by mesh headings or broad themes, we're organizing scientific literature by word use. It's more granular, and there's some surprising findings that we've gleaned. Here's another example of a visualization output for a different project that we have that we furnished. This is for a project in pulmonary medicine at Children's, and they were not interested in this. They wanted this, so we're like, that's great. So here's an example of exactly the same algorithm, exactly the same platform and pipeline, same underlying mathematical operation, but they wanted a simpler word list-based display of distribution over time and just a simple portion of corpus. So is a different output that we have. Here's an example of the final product on our platform. So our platform vision is, we want to, like I said, be like Google. We have a browser-based platform for any text corpus. So if you have any text, we're able to ingest it, and we're able to perform 3 different machine learning algorithms that are cutting edge in the field of computer science in order for you to cluster and classify and sort your data based on at the document level and the word level here. So this is one, this is a project with the Mayerson Center on adverse childhood experiences. And this is clustering that we're doing in the scientific literature there, and network clustering that we have of different clusters of words. So right now, based on our projects, we have PubMed, that NIH R1 database, but also all existing US case law and LexisNexis, Twitter, JSTOR. We have, I think, 20 different data sets that we have here, and what we're trying to prove is that our platform can really accommodate text data sets of any language type. So it can be scientific literature, it can be law, it can be any domain, sufficiently generalizable that we can feed it in and provide use and make your, like I said with Google, we try to help users make their information usable and accessible. So this is one way to take 30 million documents in PubMed and identify granular, fairly low-level word chain trends in the data set, as opposed to doing sort of the keyword search. So that's what the platform aims to do. And so those are just examples, concrete examples of some of the work we do.
So that was fantastic, and I notes of things, and I just some comments and some questions. So it lit up lots of places in my brain that don't normally get lit up. So let me see if I can keep these short and succinct, but in order. So first of all, I like a lot of things that you said about teams, particularly how challenging they are and how you often have them sitting around the table, but you have to do all the work anyway. So that's my definition of not a team. But we do that. But we do this a lot. So we break down silos by creating spaces, but still just putting people around the table and hope that something happens. So I'm here to tell you, and this is the soapbox I've been getting on a lot lately. So there's science behind this, and there are people that study the science, and there are people that practice the science. You need people that practice this science so that you don't stumble into it and sometimes succeed, but more often fail. So, you can take a shortcut. You can talk to and hire people and bring in people who understand the problem that you have and can actually work with the diverse people sitting around the table and take a shortcut to getting them functioning as a team. There are a lot of things that bring your teams together. So that's the first thing that I noticed. There are a lot of things that you were talking about bringing the teams together. Sometimes it was your tool. Sometimes it was a topic area. Sometimes it was a grant. Sometimes. So there are a lot of different things that get the people sitting around the table. Very seldom do we just randomly put people around the table and say, do something. But in some ways, that was what was behind and what's been successful about the Google model. They took what they took as a broad mission. They put people around a table and they said, your job is to make that mission real. And so some of the people sitting around the table were the data geeks. So they went out and did that. But there were an equal number of people that sat around that were all about the user experience. And if you didn't have some of each, and if you think of things that predated Google, they were clunky. The data was not the problem. The interface was the problem. So there are a lot of things that go into creating a Google model. But mostly it's the meaning behind the mission. It's much more complex than we often think about it. So there's a need to think more like that. The dissemination, I was really gratified that you brought up the issue of dissemination, because your definition of dissemination is much closer to my definition of dissemination and a long way away from the definition that most researchers and people think of as dissemination.
Yeah.
For them, when they write the dissemination sections of their grants, they write the same thing for every grant, which is we're going to publish in our area and we're going to present in front of all the people that are just like us.
Right.
And so the federal government finally has figured out that that's not even what they mean by dissemination. What they want you to do is to be in spaces that you are not normally in.
Yeah.
So having your closest 200 buddies that share a brain with you, read your work, is not dissemination anymore.
Yes.
It's having people in a very different space, reading and understanding, and not only at the academic level, but the popular level.
Yes.
You know, if you look at some of the searches and things that are most popularly read on the internet and other places, you would be amazed. It's things like physics and genomics and things like that. But it is in the space that is consumable and understandable by people in other spaces.
Yes.
So that's the dissemination that we're talking about. And you were clearly in that space.
Yes.
When I was thinking some of the other things that you were putting together, are you familiar with the book Chaos? Have you read that book? That one I'd have to think about. It's been around for like 30 years or so. But it reminded me of a short story from the author that he tells, where he was a climatologist. He was studying weather patterns. One day, he went to lunch with a friend of his who was a stockbroker. And he walked through the outer office to the inner office, and he said to his friend, "I didn't know that you were interested in the weather." And the guy looked at him really strange, and he said, "Well, I see you've got the weather trends plotted on your whiteboard out there." He said, "No, that's the last 3 years of the stock market."
Right.
But essentially, what you're looking at are underlying models, underlying realities that you see in social network analysis, you see in other things, that sort of fall into the area of complexity theory and chaos theory that permeate all disciplines. You can take these underlying models and you can plop them down in biology, you can plop them down on PubMed, you can plop them down on Twitter, and you start to see the same patterns emerging. So it's the underlying model, which actually is underlying what you're doing.
Yes.
So there truly is this underlying, not theory, but reality that crosses all of this.
And this is where the teams come in, because there are lots of research centers out there that find the underlying models and they think that's the answer.
Yes.
But they don't know why the model is like that.
Yes.
So the team aspect comes in because we need the domain experts to tell us, what does this mean?
Yes.
We can identify trends and structural features, but I have no idea what that means.
Yes.
But the person that has spent their life working on this are like, I know that already, but this is surprising.
The other thing that underlies all this, I think, is critical, is that a lot of the people that you're working with, what they are hoping to find are predictive models.
Yes.
Okay, they want to predict the next thing.
Yeah.
But the nature of social network analysis, chaos theory, complexity theory, those theories and those models are not predictive models. They are deterministic models. Work backward. They don't work forward. Which is very frustrating to the people who will use them looking forward anyway, even though they don't work that way. So, knowing the temperature today will not, with any degree of certainty, predict the temperature tomorrow.
Right.
As we've seen.
Yeah.
So we have some fundamental flaws in our brain wiring that we've got to get past. But those were all the lights that lit up when you were talking. I love them all. It was great. So they really resonated with me. Now Laura's telling me to shut up because there are other people that get questions.
Does anyone have any questions for James?
I do.
Yeah, go ahead.
So I feel like I need another PhD to kind of
Yeah.
I really enjoyed your presentation, but I didn't understand half of it because I'm not my content is, so I know about grief, and I
Closer
know
than you think.
about the functionality of grief, that's the
Yes.
body, but I know nothing about
Yes.
what I do. So being a early career researcher, how can you help me? Like, what connection do we have?
Yes. So like Jack was saying, we assume no previous experience of what we do or technical expertise at all in our domain. All you need is a research question and a mission, like Jack was saying. So if you have a clear dealing with grief or whatever your expertise is in, a clear vision of your path forward, we will translate that into a set of tools that we can answer your research question. That's often where we start. You have a plausible research question and you have a data type or data set that you need some help analyzing. Oftentimes our investigators have started off on a smaller sample set. So they've done a pilot study on 100 or 1,000 texts or a patient cohort of like 100 patients. They want to scale up. So that's oftentimes how we start.
So even if I had a data set of only 170 people, there were a lot of bio.
Yes.
That's something
Yes.
that you could help with.
Yes. So we've had several projects like that, and with a local cohort of like 100 patients, 200 patients. But what we do is compare that to national and international benchmarks, and then that bulks up our sample size, as it were. Grief, Jack was right. I think grief and emotion is a key component of some of our projects. With the Mayerson Center and Average Childhood Experiences, that crossing of experiential, emotional, but also epigenetic factors that they're interested in identifying. We are working on one project on Alzheimer's with neurology here, and we're doing this clustering on Reddit, Facebook, and e-health forum data on patient families asking about Alzheimer's. And what we found was, I think about 60 to 70% of the language clusters were based on emotion and agency. Can I do this? Why can't I do this? And also fear, hope, love, etc., laughter. And initially, our clinicians didn't buy it. They were like, "Well, this makes no sense." I'm like, "Well, it makes sense to them." So there was a disconnect in how the MDs were approaching patient family support and how the patient families were defining their problems. So there are several projects that deal a lot with emotion and how it can reflect things like epigenetics or standard of care and Alzheimer's families.
Oh, there's this private group that's several years.
Yeah.
And
Oh, wow.
long, just self-report.
Yes.
So how do you go about something that is it domain, like is it a private or?
Facebook is tricky. Facebook used to be very open, but then Cambridge Analytica happened, and now they're more selective about where they give data to. What we've done in the past with things like that is we've had people that were advocates and supporters and participants in these Facebook groups, and they asked the moderators. And then the moderators just do a poll or something, and they say, okay, this is fine if we de-identify the information. We've gotten Facebook data like that, going directly to the moderators, so we're not like hacking them. And we actually get their buy-in and approval. And then we would analyze, if we did get that data, we would kind of clustering and analyze in relation to PubMed or in relation to other bodies of text out there that describe grief. How, in their own voice, how are these people self-reporting, as opposed to how other people are describing what they're experiencing.
And how, obviously, you have to get something out of this.
Yes.
So how does that go? You get funding first, and then we approach you, or?
Oh, I see. No, you see the research question. So we're very open in this sense that I always say a prototype is free. A proof of concept is free. So if you have a data set, we're willing to free establish its viability. Sometimes there are no trends. It's like a coin flip and it's just a random scattering of data. I'm like, we might have to revisit on board about research question. But if there are trends that form and it seems promising, then we give a small seed grant of $10,000 to allow you to spend about a year or two on this. We have several investigators that are gearing up for their first K or their first R. And then what we do is give them shelter time to brush up and establish a track record of a publication or two in this domain, in the new domain that they're studying, so that when they apply for their first R, they have their biosketch publication. So that's the long answer. If your research question, prototypes and proofs of concept are free. We're happy to do that to establish viability. Once we see clear trends and it does seem like a viable research question, then we can go from there.
Anyone else? Carolyn, Sue?
Great stuff. I mean,
Hi, this is Carolyn. I couldn't find my unmute button.
it sort of keeps you up, it sort of keeps you going, doesn't it? And it's exciting stuff.
Yeah.
You need to play in a lot of different spaces.
Yeah.
I don't see anything.
So what's going on in my head?
Carlin wants to talk.
What was that?
Yes.
Carlin, one
Carlin.
more. Yeah, Carlin.
Okay, James, thank you very much. I have to be honest and say I didn't understand a lot of what this is, except that you are a place that I think we all need to, you're a person we all need to come and talk to either individually or in groups to figure out how you can help us move beyond our normal way of thinking about collecting data and analyzing data in our areas of interest so that we can move faster and better and get better, identify more people in the community. I had a meeting 2 weeks ago I pulled together people across the university who might be interested in working with me on alcohol and cancer, alcohol use during cancer treatment. And I realized as I'm listening to you that you are a person I was missing, or someone from your staff, and a librarian was also missing. But I know that there are other professionals or disciplines that were missing, and I just don't know who they are. So what is the best way to connect with you to have these conversations?
To be honest, just email me. I think that oftentimes we do initial conversations to see what are, who else we should invite to be part of the team, and we go from there. And you're right. I think that this presentation I've given several times is as broad as possible for as many different audiences as possible, but it makes most sense to people when you have a certain data type, your project, your data that you're really familiar with, and then we can start adapting it to your expertise in your domain. So if we can learn about what your research question is and what your data are, I think it'll start clicking much more.
Perfect. Wonderful. Thank you. I have so many. Must narrow down. Thank you, James. I will be emailing you.
Wonderful.
Megan, did you have a question?
I did not have a question, just some comments. Thank you so much, James. I really love the presentation, although it was hard for me to interpret some of the graphs and like draw meaning from them. What I really gathered is that this really will revolutionize so many things about research, from how we communicate it to the questions we tend to ask. And I think it will drive people from across the STEM and the arts and humanities disciplines to start asking questions about the humanity of the disciplines, and then using technology to answer those questions. And for me, I'm concerned about, sometimes I say we've been 40 years under STEM rule, where, you know, we have these STEM schools and STEM programs and the devaluing of the arts and humanities. And while there are lots of people talking about a need to reintegrate it, I feel so confident in this pathway being able to do that. So it's not just people talking about it in different corners and trying to sort of slog through this very slow cultural change. It's almost like this is a fast track to creating that cultural change. And yeah, so thank you.
Yeah, absolutely.
Megan, I'm going to jump into your space with my next comment. In that I think one of the things that comes through to me in a presentation like this is a huge gaping hole we have in our education model from undergraduate on up. And as a graduate student, I suffered through a class called the Philosophy of Science. And I wish I would have not thought of it as a burden, because I have a feeling I missed a lot that would have been relevant to your presentation. That is, there are many more things that we have in common across disciplines and differences, but that's not the way we teach. We teach things as siloed disciplines. And as a result of that, we then spend the rest of our professional careers trying to overcome that education in order to do things like this.
Yes.
But if we were to start out at the very beginning, talking about the similarities across disciplines, arts and sciences and everything else, and then building up in the specialty areas, rather than skipping that step and just going right into our silos.
Yes.
It would be much easier to work with the people around the table because they would have more in common. One of the challenges you have working with the people around any table is that they don't believe they have anything in common.
Right.
And so you have to convince them that that's not true, and sometimes you can't.
Yes.
You don't, and which means you have to carry the water
Yes.
for the team. But I think it's a fundamental flaw that we have in the way we have created education.
Yes. Yes.
And it's just hard for us to get over it.
Yeah. Absolutely.
So I'll step back out of your space.
It's hard
now.
until it's not. And I think we can get there.
So, I mean, it seems like, one of the things that we need to think about in the larger scheme of things,
Yes.
in the building and the science and tools, is that we need to rewire people's heads a little bit.
Yes.
And I think we need to put that in the mix of everything else that we're doing.
Yes. Yes. And I think, Megan, you're right. I think it's might be quicker. It can happen more quickly than we think. So with a lot of our most skeptical computer science friends that I have and engineering friends, I can say a simple fact that 75 to 80% of the data now in our world is qualitative. Text, image, videos on YouTube, sound files, and it's not structured quantitative data. So if you are only focusing on a certain data type or a quantitative family of methods, you're missing the vast majority of data out there in the wild. So if you just make that case and say your machine learning methods or your optimization methods can be applied to both qualitative and quantitative data types, they're like, okay, great. So I mean, it's a fairly simple opening to allow people to embrace a new family of data, but say you don't have to retrain yourself actually. Yes.
Here.
If we have metadata, so if we have time points associated with text, or with EHR we do because you have timestamp. But if there's time data, yes, absolutely.
James, you mentioned that you can identify areas that are funded but not over competitive.
Yes.
And I was wondering, could that be used trainees as well who maybe don't even have a research question yet, of interest, and they want to find out where are the empty spots?
Yes, yes. So yeah, we're working with several investigators at Children's. So competitive for grants. Their incentive structure is based on grants. So yeah, it's not really a research question. It's oftentimes junior faculty going through the first R, and they said, I cannot mess this up. Or
Tell me what to do it on.
yeah,
Yeah.
or a PI that has a large lab and is like, I have 5 grad students that I do not want to mess up their careers. And almost all of them say right now they do manual literature review. And
Yeah.
their gut instinct in the field, like I think I've read hundreds of articles, this is what I think the field is like, but our clustering allows them to see, wow, in the center of the field, this is really oversaturated. There's a lot of money there, but here's a small pocket of, it's a statistically significant pocket of publication and grants, but that's not oversaturated. And maybe we should be diverting our efforts
That's a
there.
great place for a trainee to go. Yeah.
Right. And they often have more multidisciplinary. We see the more siloed, genetics example is our most successful project today. The standard genetics publications and grants are at the heart, but then there's these more multidisciplinary biomechanical engineering and then genetics projects that are separate branches that they're diverting to.
So lot of people.
Yeah.
And, you know, this just really got me going.
Yeah.
But I'm wondering about the other audiences, because I recognize that a lot of people who preface their comments and questions with, I didn't understand half of what you said.
Yeah.
So, are you getting a lot of, but what kind of reaction are you getting from audiences? Is it, I don't understand what you're doing, but it sounds cool to me? Or, you know, how much, I'm curious about what you're getting by way of feedback.
The tricky thing is that I have to present to a lot of different audiences, from the trustees that are largely business people, all the way down to grad students and practitioners in the field and everything in between. So I don't want to go. There's a bad type of presentation in this domain, this space, that is like AI, and I think that is too vague. I try to stay grounded in actual examples and our actual practices, and I try to explain in a way that's general enough that people can gain an entry point. I also have been in talks where if I'm too general, I have a skeptical computer scientist in the room and starts to say, you know, blah, blah, starts picking holes in me. So we have to sort of encompass a lot. So
I'm just really curious about that, because it's a complex message, and if people try to read everything on your slides or follow it at that level, yes, I think that's not the message. The message is not every line that you have.
Of course,
But I'm just curious, what, you know, are you getting good uptake here?
Oh yeah, absolutely.
All right,
absolutely.
fantastic. Fantastic.
Both from leadership and grant funding agencies, but and I asked email Laura last night about the complexion of the audience, because it just helps me to see am I dealing with a very technical audience. Like when I presented to the biomedical informatics division of children's,
Oh my God.
I was much more technically focused as opposed to the trustees. Same slides actually, but I just
Words.
No, I think that's great.
That's good. That's a good skill to have.
That's my daily life.
I think we are very much, this group is very much a complex social network. So we spread out into lots of different areas and can carry the message of the tool and the message of what you're doing to a lot of different. And also bring, you know, people in. But the other thing we can do is we can insinuate the skills around team science and team building and those into the situations where you're finding that you're trying to apply this to a transdisciplinary group. So, you know, call us, please, you know, when you get to that situation and you would like to sort of take that shortcut. Because
I think, as we've discussed before, you really have grounding and a really good sense of the culture needed and the sort of connective tissue needed for science. Whereas I think what we've tried to do is a sort of a methodological, technical underpinning at the level of data sets, data structures, etc. So I think
and it'd be fun for us.
Yeah, you have a team that's stuck who can assess that and then intervene or tell you how to intervene.
This is very helpful. Thank you so much.
Thanks for
Is that
inviting me.
helpful for you?
Yeah. Thank you,
You
Sue.
know, this is like Christmas for me. I love these, you know.
Thank all of you. It was a great presentation. I really appreciated it. Have a great day.
Thank you very much.
Bye.
Bye.